All right, welcome everyone. Today we're going on a pretty incredible journey. We're going to start way, way out in space to really get a handle on our planet's place in the universe. And then we're going to zoom all the way back in to the very ground right under our feet. So let's dive in. So let's start with a couple of big questions. Have you ever really stopped to think about why the sun rises and sets every single day? Or why we have this reliable cycle of summer, fall, winter, and spring? They seem like simple questions, but the answers are all about the amazing way our planet dances through space. The secret to understanding all of this, day, night, and the seasons, really comes down to two fundamental movements that our planet is making constantly. Every second of every day, it's doing this dance. Let's break those two big moves down. First thing you need to know about is the Earth's axis. Just picture an imaginary line, a pole, running straight through the center of the Earth, from the North Pole all the way to the South Pole. You know how a spinning top has that point it spins around? Well, that's basically what the axis is for our planet. And that brings us to our first big move, rotation. It's exactly what it sounds like. It's the Earth spinning, or rotating, on that imaginary axis. This is the planet's daily spin, and yep, it's happening right now as we speak. Now the second big move is called revolution. So while the Earth is doing its daily spin, it's also on a much, much longer journey. Revolution is the path, or what we call an orbit, that our planet takes as it travels all the way around the sun. Think of it as our planet's huge, year-long road trip. Okay, so let's put these two side by side to make it super clear. Rotation is the spin on the axis. It takes 24 hours to do one of those, and that's what gives us day and night. Revolution, on the other hand, is the journey around the sun. That takes 365 and a quarter days, and that is what creates our seasons. Two totally different moves with two totally different results. So now we know the moves in this cosmic dance, right? Let's look at what that actually means for us down here on the ground. How do these motions actually shape our daily lives and the entire year? Here's a cool little detail. The Earth rotates from west to east, and because we're all just passengers on this giant spinning ball, it creates this perfect illusion that the sun is the one moving across our sky. When your little spot on the planet turns to face the sun, boom, you get daylight. And as it keeps spinning and turns away from the sun, you get night. It's really that simple. But here's the number that changes absolutely everything. 23.5 degrees. What's that? Well, that's the tilt of the Earth's axis. See, our planet isn't sitting straight up and down in space. It's leaning over just a little bit. And that slight tilt is the real secret ingredient for the seasons. A lot of people think seasons happen because we get closer or farther from the sun, but nope. It's all about the angle of that tilt. So let's track this for the southern hemisphere. In December, that whole half of the planet is tilted towards the sun. It's getting more direct sunlight, more heat, and that's summer. Then, by June, it has traveled to the other side of its orbit, and now it's tilted away from the sun. The light is less direct, and that's winter. March and September are those perfect in-between points, which give us autumn and spring. Okay, so we've seen how the Earth moves through space. Now let's zoom our journey way in. We're leaving orbit, we're coming down through the atmosphere, and we're landing on the surface. We're going to shift from the planet's cosmic dance to the very ground we stand on. What is this stuff actually made of? We all live on what's called the Earth's crust. It's that hard, rocky outer layer of our planet. And even though it feels incredibly solid and massive to us, in the grand scheme of things, it's just a really thin skin on the planet, only about 70 kilometers thick. Now, if you could just take a giant shovel and dig straight down into that crust, you'd find these different layers of soil. Right at the top, you've got the good stuff, the rich topsoil. Dig a little deeper and you'll hit the subsoil. Below that, there's a layer of broken up, weathered rock. And finally, if you dig deep enough, you'll hit solid rock, which is also called bedrock. So that brings up a pretty amazing question, right? How does that solid, dead rock way down at the bottom transform into the rich topsoil at the surface that allows pretty much all life on land to exist? Well, it's a very slow, kind of magical recipe. A super important ingredient in that recipe is something called humus. Now, this isn't really a separate layer of soil, but it's a vital part of the topsoil. Humus is just what's left over after plants and animals have totally decomposed. It's a dark, organic material that is absolutely packed with nutrients that plants need to grow. Think of it as nature's perfect plant food. And the actual process that turns rock into soil, that's called weathering. This is the natural force that takes massive solid rocks and, over huge amounts of time, just weakens them and crumbles them into the tiny little particles that make up soil. And one of the most powerful kinds of weathering is driven by something really simple: water. It goes like this. Water seeps into a tiny crack in a rock. Then, the temperature drops and that water freezes. Now, when water turns to ice, it expands with incredible force, and it pushes that crack a little bit wider. Then the ice thaws. The water seeps even deeper into the now bigger crack, and the whole cycle repeats, until eventually, the rock just breaks apart. But it's not just physical force. Rocks also get broken down by chemical weathering. You can think of it like rust on a car. Reactions with things like oxygen and water can literally make rock crumble. And then there's biological weathering. That's life itself doing the work. A tiny little plant root can grow into a crack and eventually split a huge boulder. Or animals burrowing in the ground constantly churn things up. It all helps. So you take all that weathering, you mix in that vital humus, and what do you get? Topsoil. And as we're about to see, this thin skin of our planet is one of the most critical and most fragile resources we have. But, not all soil is the same. You've got clay soil, which holds on to way too much water and gets hard as a rock when it's dry. Not great for plants. Then you have sandy soil, where water just drains right through, so it's too dry. The absolute best soil for growing things is loam. It's this perfect, balanced mix of sand, clay, and that all-important humus. It holds just the right amount of water and nutrients. And here's the kicker. This perfect topsoil is so precious because it takes an unbelievable amount of time to form. Are you ready for this? To create just 10 centimeters of topsoil, that's less than the length of your hand, can take nature about 1,000 years. And what takes a millennium to build can be lost in a flash. That's the danger of erosion. It's the process where that precious topsoil just gets carried away by wind or washed away by water, often way faster than nature can replace it. So why does that matter so much? Well, because topsoil is the foundation of almost all life on land. I mean, think about it. If you lose the topsoil, the plants can't grow. If you lose the plants, the animals that eat plants have no food. And if they disappear, the animals that eat them have no food. The entire food chain is connected, and it all starts with that thin layer of soil. So we end our journey here, back on the surface, with one last, really critical question. We've seen how our planet's dance gives us our days and seasons, and how thousands of years of weathering gives us the soil that keeps us alive. Knowing all of that, knowing how precious and slow to form it is, how can we protect it